In this video, we're going to be talking about inverse trigonometric functions and how to evaluate them without using a calculator. So an inverse function is basically where we are finding the angle, but we've been given the trig function. Now the definition of a trig inverse function, you want to look at the unit circle and then find the radians. So let's do an example. So we're going to find the radians that have a sine of 1/2. So here we have our unit circle. And so we want to find the radians that have a sine of a positive 1/2. Now remember that sine is the y value. So we'll go around and we'll look at all of our y values, and we're trying to find all the positive 1/2s. And so we see here that there's only two options. And so we want the smallest of those options. And that occurs here at 30 degrees or pi over 6. And so we call this the general definition. Now, trig functions are usually written as sine raised to the -1 power of theta, cosine raised to the -1 power of theta, and tangent raised to the -1 of theta. So this is saying the inverse of sine of theta, inverse of cosine of theta, and the tangent, the inverse tangent of theta. Now, sometimes you might also see them written as the arc sine of theta. So if you see that, that just means the inverse of sine of theta. It's that same thing. Okay, so if you see arc, that's what it's also referring to. Now let's take a look at the domain and the ranges that we might see in our inverse trig functions. So here we see that for our arc sine, or our inverse of sine, we have a domain that goes from -1 to 1, and a range that goes from pi over 2 to negative pi over 2. Our intercept here occurs at 0, 0. This is considered an odd function, and it has origin symmetry, meaning I could rotate it around the origin and have it land on top of itself. Let's take a look at our arc cosine, so our inverse of cosine. So our inverse of cosine, here we see that we have a domain between -1 and 1, and we have a range from 0 to pi. Here our y-intercept is not at the origin, but is at 0, pi over 2. Our arc tangent is the inverse of tangent, and here you're going to notice that we have a domain that goes from -infinity to +infinity. So our x can be anything we want it to be. Our range is going to be set between pi over 2 and negative pi over 2. These are also our horizontal asymptotes. Now, if we were to turn this graph and to have graphed this, it would look something like that, with our asymptotes here and here at negative pi over 2 and pi over 2, and this would be our normal tangent function. So notice that it's been almost rotated 90 degrees. Almost. We're going to have an x-intercept at 0, 0, and this is considered an odd function, and it has origin symmetry. So how can we use this to help us evaluate a function without using our calculator? Sometimes this might be a little bit overwhelming to think of it in this particular manner. And so we can also think about it as like, which quadrants is this going to happen for us in? So kind of a little shortcut is that you'll find your sine functions in the first and fourth quadrants. Cosine will be in the first and second quadrant, and then tangent will be in our first and fourth quadrant as well. So let's put this into practice. So in this example, we're going to be evaluating the expression without using a calculator. So we're going to give our answer in both radians and in degrees. So for letter A here, we have the inverse of sine of radical 3 over 2. So we're going to want to use a unit circle to help us with this. So here we have our unit circle. And so we're going to look at the unit circle and see where sine is a positive radical 3 over 2. Now in doing so, remember that sine is y. So if we look, we can see that y is a positive radical 3 over 2 here, and then here, and that's it. So we have two answers. But remember that our answer should only be in either the first or the fourth quadrant. And so the only place that works for us is here in this first quadrant. And so we're able to say that the inverse of sine of radical 3 over 2 is at 60 degrees in degrees, and then in radians we would say pi over 3. And that would be our solution. Let's try another one. So here we're going to find the cosine, the inverse cosine of -1. And remember that the cosine of theta equals x. So again, we'll look to our unit circle, and this time we're going to look to see where we can see cosine or x equaling a -1. So we'll look at our x's, and we see that happening here, and that's it. So that's going to tell us, also looking here, we know that our answer should have either been in the first or the second quadrant. And here we see it's in our second quadrant. So we're going to write down that the cosine, the inverse cosine of -1 is occurring at 180 degrees. And that the cosine, the inverse cosine of -1 is equal to pi. So here we have our solution. I want you to go ahead and try letter C on your own. So remember that the tangent of theta equals y over x. Remember to use your unit circle to help you. So go ahead and push pause, and when you're done, push play, and we'll see if you were right. So here's we're looking for tangent. Because we want our answer to be a -1, that means that our y must equal our x. So y must equal x. But one of them must be negative in order to get the -1. So we want to know, where does y and x equal each other? And we see that that happens here, but they're both positive. So that's really not going to help us there. But it happens there, and it happens again here, where they're the same numbers except that one is positive and one is negative. So we see that we have values at 3 pi over 4 and 7 pi over 4, except that our answer can only be in either the first or the fourth quadrant, because that's where our domain is. So that tells us that our answer is going to need to be in the fourth quadrant. So we can then say that the inverse tangent of -1 equals -45 degrees, and the inverse tangent of -1 equals -pi over 4. So why is it a -45 degrees instead of a 315 degrees? And why is it a -pi over 4 instead of 7 pi over 4? Well, here we have our initial side, and then we have our terminal side here of our angle. And we're looking for our coterminal angle. So our original angle kind of comes all the way through here. But we can't exist in this area, so you can't go that direction. Not allowed. So the only way to get there would be to be taking our coterminal, right? We need that kind of that coterminal. How else can I get there? By only using the first and the fourth quadrant. And we can get there by doing a -45 degrees. And so that is why we have a -45 degrees and a -pi over 4 as our solution. So you can't go into a quadrant, right? You can't go into a quadrant to get someplace if you don't exist there.